Hi, again myself Mrs. Satabdi Dhar is here with you to discuss about some of the parts of process management like threads, etc. So keep watching. So from Unit 3, which is process management, we are going to discuss here about what are threads, benefits of that, and different types of threads like user level thread, kernel level thread, and different types of multi-threading models. Now, here is the first an important question that what is thread? In computer science, a thread of execution is the smallest sequence of programmed instructions that can be managed independently by any scheduler. A thread is a follow-up execution through the process code with its own program counter that keeps track of which instruction to execute next. System registers, which hold its current working variables, and a stack which contains the execution history. A thread is also called a lightweight process. Threads provide a way to improve application performance through parallelism. Threads represent a software approach to improving performance of operating system by reducing the overhead thread is equivalent to a classical process. Now, what are the advantages of thread? Threads minimize the context switching time. Use of threads provides concurrency within any process. Efficient communication. It is more economical to create and context switch threads. Threads allow utilization of multiprocessor architecture to a greater scale and efficiency. Each thread belongs to exactly one process, and no thread can exist outside any process. Each thread represents a separate flow of control. Threads have been successfully used in implementing network servers and web server. They also provide a suitable foundation for parallel execution of applications on shared memory multiprocessors. The following figure shows the working of a single threaded and a multi-threaded process. Now, what is single threaded process? In computer programming, single threading is the processing of one command at a time. The opposite of single threading is multi-threading. In the formal analysis of the variables, semantics, and process state, the term single threading can be used differently to mean backtracking within a single thread, which is common in the functional programming community. Now, what is multi-threading or multi-threaded process? Multi-threading is mainly found in multitasking operating system. It is a widespread programming and execution model that allows multiple threads to exist within the context of one process. These threads share the process resources but are able to execute independently. The threaded programming model provides developer with a useful abstraction of concurrent execution. Multithreading can also be applied to one process to enable parallel execution on a multiprocessing system. Now, one of the most important questions in this chapter, we are going to know that difference between process and thread. Process is heavyweight or resource intensive. Thread is lightweight, taking lesser resources than any process. Process switching needs interaction with operating system, whereas switching does not need to interact with operating system. In multiple processing environments, each process executes the same code but has its own memory and file resources. whereas all threads can share same set of open files child process in this thread. If one process is blocked, then no other process can execute until the first process is unblocked. Whereas, while one thread is blocked and waiting, a second thread in the same task can run. Multiple processes without using threads use more resources, whereas multiple threaded processes use fewer resources. In multiple processes, each process operates independently of the others. One thread can read, write, or change another thread's data. The two types of threads are user threads and kernel threads. User threads are above the kernel and without kernel support. These are the threads that application programmers used in their program. And kernel threads are supported within the kernel of any OS system. All modern operating systems support kernel-level threads, allowing the kernel to perform multiple simultaneous tasks and or to service multiple kernel system calls simultaneously. Now, what is user-level threads? In this case, the thread management kernel is not aware of the existence of threads. The thread library contains code of creating and destroying threads. For passing message and data between threads, for scheduling thread execution, and more saving and restoring threads context. The application starts with a single thread. About the advantages of user-level threads, thread switching does not require any kernel mode privileges. User-level thread can run on any type of operating system. Scheduling can be application specific in the user-level thread. User-level threads are fast to create and manage. And about the disadvantages, in a typical operating system, most system calls are blocking. Multi-threaded application cannot take advantage of multiprocessing. The other type of thread is kernel level threads. In this case, thread management is done by the kernel. There is no thread management code in the application area. Kernel threads are supported directly by the operating system. Any application can be programmed to be multi-threaded. All the threads within an application are supported within a single process. The kernel maintains context information for the process as a whole and for individuals, threads within the process. Scheduling by the kernel is done on a thread basis. The kernel performs thread creation, scheduling, and management in kernel space. Kernel threads are generally slower to create and manage than the user threads. Now, about advantages of the kernel level thread. Since kernel has full knowledge about the threads in the system, scheduler may decide to give more time to processes having large number of threads. In one thread, in a process is blocked, the kernel can schedule another thread of the same process. Kernel routines themselves can be multi-threaded. It is it is good for applications that frequently block. Now, what are the disadvantages of this kernel level thread? Kernel threads are generally slower to create and manage than the user threads. Transfer of control from one thread to another within the same process requires a mode switch to the kernel. The difference between user level and kernel level threads is as follows. User level threads are faster to create and manage, whereas kernel level threads are slower to create and manage. Implementation is by a thread library at the user level, whereas operating system supports creation of kernel threads. User level thread is generic and can run on any operating system, whereas kernel level thread is specific to the operating system. Multi-threaded application cannot take advantage of multiprocessing, but in kernel level thread, kernel routines themselves can be multi-threaded. Now, what are multi-threading models? Some operating systems provide a combined user level thread and kernel level thread facility. Solaris is a good example of this combined approach. In a combined system, multiple threads within the same application can run in parallel on multiple processors, and a blocking system call need not block the entire process. There are three types of multithreading models: many-to-one relationship, one-to-one relationship, and many-to-many relationship. The first one is many-to-one model. Many-to-one model maps many user-level threads to one kernel-level thread. Thread management is done in user space by the thread library. When thread makes a blocking system call, the entire process will be blocked. Only one thread can access the kernel at a time. So multiple threads are unable to run in parallel or multiprocessors. Thread management is handled by the thread library in user space, which is efficient in nature. The next one is one-to-one model. There is one-to-one relationship of user level thread to the kernel level thread. This model provides more concurrency than the many-to-one model. It also allows another thread to run when a thread makes a blocking system call. It supports multiple threads to execute in parallel on microprocessors. The one-to-one model creates a separate kernel thread to handle each and every user thread. Most implementations of this model place a limit on how many threads can be created. Linux and Windows from 95 to XP implement the one-to-one model for threads. And the last one is many-to-many model. The many-to-many model multiplexes any number of user threads onto an equal or smaller number of kernel threads, combining the best features of the one-to-one and many-to-one models. Users can create any number of the threads. Blocking the kernel system calls does not block the entire process. Processes can be split across multiple processors. Hope through this video I can make you understand about what are threads, benefit of threads, user and kernel level threads and their differences and different types of multi-threading models. Thank you and keep watching. In my upcoming video, I am going to discuss all about deadlock scheduling algorithms, which is going to be very interesting. So wait for that and don't forget to subscribe my channel.